Welcome to BSc Statistics students. In this lesson, I explain two definitions: contrast, orthogonal contrast. Okay. What is meant by a contrast? So, if you consider K treatments, and the means of K treatments are T1, T2, and so on Tk. These are K treatment means, that is average yield. Average yield from the K treatments observed, average yield observed, taken, obtained, average yield obtained from K treatments, that is T1, T2, and so on Tk. But if you consider a linear combination means, for example, C1, C2, Ck are constants, then C1, T1 plus C2, T2 plus and so on plus Ck, Tk, which means summation I is equal to 1 to k Ci Ti. This is called linear combination. The linear combination summation I is equal to 1 to k Ci Ti of K treatment means, that is T1, T2, Tk, of K treatment means is called contrast. Contrast is called contrast of treatment means. If summation I is equal to 1 to k Ci, the constants, if you add the constants, it must be equal to 0. If summation I is equal to 1 to k Ci is equal to 0, that's all. The definition of contrast. Contrast is nothing but if you consider K treatment means T1, T2, Tk, and it's convex, it's linear combination. Summation I is equal to 1 to k Ci Ti. It's a linear combination of K treatment means, which is called contrast. If summation I is equal to 1 to k Ci is equal to 0. That is the definition of contrast. Now come to the orthogonal contrast. What is meant by orthogonal contrast? For which you have to consider again, for example, T1, T2 and so on Tk are K treatment means of K treatments obtained from the K treatments. Then two contrast you have to consider of K treatment means. First one, I am considering the first one, a summation I is equal to 1 to k Ci Ti, and in which if this is that is the linear combination of summation I is equal to 1 to k Ci Ti, that is linear combination of K treatment means is called contrast if summation I is equal to 1 to k Ci is equal to 0. This is the first contrast I have considered. Second contrast, you consider another one, summation I is equal to 1 to k. For example, d is the another constant Diti, and in which it is said to be contrast summation I is equal to 1 to k Diti, that is a linear combination of K treatment means T1, T2, Tk. Another linear combination is said to be of K treatment means is said to be contrast if summation I is equal to 1 to k Di is equal to 0. So these are the two linear combinations we have considered. The first one, it is a contrast. Second one, it is also another contrast. So therefore we have considered two contrast. When they are said to be these two contrast, when they are called orthogonal, that is two contrast, when two contrast are called orthogonal, we have one condition. If summation I is equal to 1 to k Ci Di, if you multiply the two constants C and D, then that is and add the summation Ci Di, summation I is equal to 1 to k, it is equivalent to 0. Then these two contrasts are said to be orthogonal. These two contrasts are said to be orthogonal. Hope you understand. So first of all contrast and then orthogonal contrast. If you consider two contrasts and which are said to be orthogonal if summation Ci Di is equal to 0. Thank you.